In this problem, we have a sequence of length A consisting of numbers from 1 to n, but the sequence may contain duplicates as well. And the key thing to know is that the size of the sequence is n. So in this problem, we'll take a set of size m, and if the maximum of this set minus the min of this set is less than or equal to k, we increase our count by 1. And in the end, we want to find what this count is. So we want to find the number of tuples of size m such that the max minus the min is less than or equal to k, and that mod 1e9 plus 7, because in this case our number can be very big. So this is the exact same question as the easy version, except m is now not fixed to 3 and k is not fixed to 2. But that really doesn't change anything much, because we'll just use the same method as we used in E1, right? So what we do is, let's say we have our sequence A is going to be like 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, 4, 5, 5, 5. If this is our sequence, then we make a frequency list. So I just call that a frequency, and then the numbers are 1, 2, 3, 4, 5, 6. So for ones, we have 1, 1, 3, 2s, 4, 3s, 4, 4s, 4, 5, and 2 6s. Oops, 6. Yeah. And from this, we just, let's say, in the previous example, k was 2, right? So we would look at 3 numbers next to each other, because the maximum difference between any 3 numbers is going to be 2. And, well, any 3 numbers that are next to each other in this frequency table, their maximum difference was going to be 2. And then we just looked at the number of numbers in A such that it was either 1, 2, or 3, and in this case it's 8, and then we only had to choose 3 of them, so that's just 8 choose 3. And then we do that same here. If k was 2, we look at 3 numbers again, and so on and so forth. So what we notice that, let's say if k is 4, then we'd be looking at 5 numbers, right? Because 1 here, because 5 minus 1 is 4, and it's less than or equal to. So we will always be looking at a group of k plus 1 numbers. And from this group of k plus 1 numbers, we just have to choose not 3 anymore, we have to choose m of them. So once we choose these m, then we just add them all up, and just like in E1, we need to count the duplicates, right? So why? So again here, let's say in this case we are looking at when k is 4, right? So again, we're looking at when k is 4 and m is, I don't know, let's say 2, right? So here we will be looking at the 2 sets 1, 2, 3, 4, 5 and 2, 3, 4, 5, 6. Now in 1, 2, 3, 4, 5, since we're choosing here m is 2, right? Since we're doing what this is 12 plus 4, 16, right? 16 choose 2. And in the 16 choose 2, one of the pairs or sets that it'll count will be 4, 5, right? Which is valid. But if you look at 2, 3, 4, 5, 6, this same set will be counted again in this, what, 17 choose 2. So this set 4, 5 is counted twice, once while looking at the group 1, 2, 3, 4, 5, and again when looking at 2, 3, 4, 5, 6. So we again have to get rid of it, and the way we do that is we look at exactly these k numbers, and then so the overall sum here would be 15, and then we do 15 choose 2. And why is that? So if you look at 2, 3, 4, 5, this, like the pair 2, 3 would be counted once here, once here. The pair 2, 4 would be counted again once here, once here. So we care about the overlap, right? and the overlap between 1, 2, 3, 4, 5 and 2, 3, 4, 5, 6 would be these four numbers. And to count the number of valid sets that we overlap, it would just be the sum. So here, which is 15, and 15 choose 2, because each set is of size 2, and then we choose 2 of them. So yeah, it's the exact same logic as E1, except we just have to make it broad because we aren't having a fixed value of m and k. So yeah. Okay. So we have, I think we have to optimize choosing now, because now it's no longer n choose 3, it can be n choose k. So, okay, so first thing first, int t equals, int t, c, and t, while t minus minus, we solve. And now, so fact 0 equals 1 for I between 2 and times 2, fact I equals fact I minus 1 times I mod, and then fin max, what is it, times 2 minus, yeah, times 2 minus 1 is the inverse of max times 2 minus 1. And then the last one, what would it going to be? It's going to be for int I equal max times 2 minus 2 minus I means that fin I equals fin I plus 1 oops, I plus 1. So I'm just doing the code that we need to calculate and choose R really quickly. Okay, let me just do that quickly and then come back. So that's what I'm setting. So then we have a const long max 26 plus some leeway, and then mod is just 29 plus 7 as usual. We just preset all these arrays, max times 2 and fin max times 2. That should work. And now calculate and choose our fast. We need two helper functions. One is calculate power in log time, so that'll be long A, long B. So our answer is initially 1, so while B is bigger than 0, if B is odd, answer equals answer times A mod. Yeah, that's right. And then we just do A times equals A equals mod. So we do A times A and then we mod it, and then B divided equal to 2. Return R. Yeah, so this finds power in log time, and then define the inverse given a number x. So for a little theorem, then R equals 1. So while if E is odd, R equals R times X. We're going to mod that. We could go over, then X equals X times X mod, mod, then I can get this shit. Okay, now calculate NCR. So we're given N and R. If R is less than 0 or R is bigger than n, then we just return 0. Otherwise, we return back a times fin b mod times fin a minus b mod. Oops. N r n minus r n factorial over r factorial times n minus r factorial. Yep, okay, that looks good to me. Hopefully I didn't make any mistakes there. And now just to go over the same logic as last time. So this time, instead of just being given in n, we're also given m and k, so we read those in. Vector L, call it a, so let's keep that constant. Actually, since k, so if you're looking at our answer to E1, actually, this is fine because our value of k is small, but if k can go up to 2e5, so doing the operation over and over again in a for loop becomes very taxing. So we need to do this in a prefix sum. So we'll just call this prefix sum. So yeah, that's why it goes to n plus 1. So then for n, just again we read in x and then prefix sum of x plus plus. For I between 1 to n plus 1, prefix sum I plus equal to prefix sum I minus 1. This is how you calculate the prefix sum. So once we have the prefix sum, we can try and find the answer right now. So initially the answer is 0. For I between minus k and n, we can just say the sum is equivalent to, so it will be prefix sums so what is so the max would be I plus k plus 1, right? And then the min would be just I. Wait, but I don't know, actually since we're going from minus k, it would be max of I 0, and to go all the way till n, it would be min of this and n. Okay, why is this? Okay, let me just redo that. Then we ans plus equals ncr, then ans mod equals mod. Okay, so the key thing here is this boundary from minus k all the way until n minus 1. So why is that? If we have some frequency list, I don't know, 3, 4, 5, 6, 7, and let's be, we have 9, 8, 7, 2, 3. Yeah. So in one set we can have all 3s. Then in the next set we can have 4 and 3. The next set we can have 3, 4, and 5, and then all the way until we reach a size of m, and then we start kicking things out. So this is just a. So all I'm saying is let's say here we fix k equals 2, right? Initially, I look at it as being empty. Then I look at only the first element, then the next 2, then the next 2, then the next 2, the next 2, and then this and nothing else. So I just go through groupings of size k that start off with just the first element and end off with just the last element. So that's what this for loop does. And since we start off here, there are times where the value of I is less than 0, which is, yeah, could we start off with minus k, and there are times where the value of I plus k plus 1 is bigger than n, so that would go out of range, so we just use the max value in our prefix sums. So this is to count, and now you take away the number of tuples that we counted twice. So the way we do this is the exact same logic, except we start off with minus k plus 1 all the way till n. And then the sum is, just join this and paste that here, except now it would be from 1 till k, and this would be minus equals. And since we're subtracting, we don't have to mod because there's no issue of overflow, but there is an issue that we go lower than 0. So if our answer is less, so while our answer is less than 0, then answer plus equivalent to mod. So this just ensures that our answer is never less than 0, and then we see out our answer new line. Okay, silly mistake here. With that, I think with that, if we do it by 2, okay, that's not good. Wait, let me just check this first. 1e6 plus 50, 1e9 plus 7, nax times 2, nax times 2 power, result equals 1 while b is bigger than 0. If it's odd, r equals r times a mod mod. A b r equal to return r. Okay, that looks good. Mod minus 2r equals 1 while e, if e and 1, r equals r times x mod mod. X equals x times x. I don't know if that makes a difference. Probably won't. If b is less than 0 or b is bigger than a, then we return 0. Otherwise, you return the factorial of n times r over n. Yeah, n over r times n minus r. The n factorial over r. That looks good to me as well. Is it the setting of the factorial that I messed up? Because very small mistake here. So fact 0 equals 1 for I between, should be 1 times max times 2 fact I. Okay, yeah, that is just a silly mistake when I set up the code for factorial. Yeah, this code for factorial is pretty well known. I think there should be a video by someone like Erich or something on this, but it's a very straightforward concept in which basically if you choose something, the formula is n factorial over r factorial times n minus r factorial, and that's, we're doing n choose r, and we just calculate n factorial, r factorial, and n minus r factorial really fast. But the but when you say inverse, we just calculate 1 over, yeah. So just a really fast way to calculate choosing. So let's just submit something. Okay, wrong one. Hopefully this goes through. And voila.